Alright, so now let's start with the scenario of San Lorenzo where you need 2 scoops of ice cream mandatory and there's no syrup. So for example, for part A, it could be like chocolate ice cream and a chocolate ice cream, double chocolate ice cream, pistachio ice cream and strawberry ice cream, and it could be like a vanilla ice cream and chocolate ice cream. They all sound really good. So let's start with B. So now B is saying that, well, with the given scenario, the given situation, how many combinations are possible? So now just look at the table next to me. So we're just going to take out the boxes or the squares that are the same ice cream flavor combinations. So for example, I'm talking about like chocolate ice cream and chocolate ice cream combinations, or strawberry ice cream and strawberry ice cream combinations, right? So if you look, you might think, well, there might be 12, or there is 12 combinations, right? Well, not quite. If you look at it carefully, the 12 ice cream actually has pretty much 6 different combinations. And why is that? Why did 12 become 6? And the reason behind this is because, well, if you look at it closely, strawberry ice cream and vanilla ice cream combination, for example, is the same thing as vanilla ice cream and strawberry ice cream. They're just flipped, right? The order is flipped, right? So maybe the order of how you put in ice cream is different. Again, for example, chocolate ice cream and vanilla ice cream is the same thing as vanilla ice cream and chocolate ice cream, right? So you have to divide it by 2 from 12. So 12 divided by 2 is 6. But we're not done with 6 yet, right? Don't forget the blank squares that we have, right? Which are the same flavor combinations, chocolate, chocolate, strawberry, strawberry ice creams, right? Kind of like that. So if you have to add 4 to 6, so 6 plus 4 equals 10. So for B, there's actually 10 total combinations of ice creams that you can have. Alright, now let's start with C now. So C is pretty much the same question as B, but we're adding another flavor. So again, look at the table next to me, but this time we already removed the same flavor combinations that are pretty much the same but with different orders, right? So again, I'm talking about like strawberry ice cream and vanilla ice cream, which is pretty much the same thing as vanilla ice cream and strawberry ice cream. So the left side of the table, they're all gone. We just took them out. So if you count them correctly, right? So we added a 5. So there's actually 25, but because there's the same flavor combinations, which are 10, right? So we remove 10. So there's 10 empty boxes. So which means that there's 25 minus 10. So there's 15 different combinations of ice cream. Now let's start with D. So D is asking about the visual representations that we can do with the given scenario. So as you can see next to me, there's a tree diagram. And at first it branches from 4 different ice cream flavors. But again, for each ice cream flavor, there's again 4 different branches, so the 4 different flavors of ice cream. However, as previously stated in the explanation, you can see that there's the same combinations of ice cream, but they're just in different order. So we have to remove that. So if you look at the right side of the tree diagram, you can see that I have put in a little key where it shows that these combinations are the same flavors. These are the same thing. So we have to remove the total combinations. As we can see, is 16 at first from the tree diagram. But again, from the key on the right side, you can see that there are same 6 combinations. So we have to remove 6 from 16. So 16 minus 6, which is 10. So again, there's 10 different combinations. Right, so for the 5 flavors for that visual representation, again, we're using a tree diagram. And you can see right next to me that, well, again, it's pretty much the same thing. So 5 branches of ice cream flavors. Then again, for each ice cream flavor, it branches out another 5 ice cream flavors. So again, it might look like there's 25 different combinations. However, again, we have the exact same combination flavors, right? But they're just in different order. So it's on a key on the right side of the tree diagram. So you can see, for example, I put vanilla and strawberry equals strawberry and vanilla, and so on and so forth. They're really the same thing. So we have to remove those combinations, which are 10 of them in this case. So 25 minus 10 is 15. So in this scenario, there's 15 different combinations.